Now you will learn about interfaces. So an interface is something that can only contain public abstract methods and constants. And we'll focus on public abstract methods for now. So basically, for example, right here this interface contains a public abstract void display. Of course, that has no body. It turns out that we don't need to actually put abstracts right here because it's an interface, so any method in the interface will automatically be abstract. And another thing, if we try to make this private, it's not going to work. If we try to make this protected, it's not going to work. It can only be public. If we try to make it default, it's actually going to be public. So basically in an interface, this is generally how you make a method because you do not need to put the public and abstract. Java will automatically make this display method public and abstract. And now how do you use an interface? Well, let's just say we have a class right here. Now, the way we use this interface is class A implements displayable. So basically now, all of a sudden, A has the display method. Now, of course, the display method is abstract. A is not abstract. That means that we need to override the display method. So public void display and do something like print value A. Now, so far, interface just seems like an abstract class except with less features. So what's the use of an interface? Well, we can demonstrate with this example. Say we have vehicle void accelerate void brake and say something like that. And now we have a class named car. So car can implement vehicle, and now basically if we have a car like this, and car implements vehicle, we must have that car overrides the accelerate and brake methods. So public void accelerate and then now say if speed is at least max speed, then I don't speed up. So if speed is less than max speed, then I do speed up. Similarly, brake if speed is greater than 0, speed minus. Another thing, note that if we try to make this thing private, it won't work. Basically, you cannot override a public method to private. So a public method cannot be overridden to private. Or in general, even if I try like default, it won't work. Basically, in general, a method cannot be overridden to a lower access mode. So for example, default can also not be like modified to private. And that makes sense as well because we should be able to call it from superclass variable, so it should work. It should not be a lower access mode. Now, here's why we want interfaces rather than abstract classes. If you've noticed, every single class so far we've created has only extended one class. In general, classes can only extend at most one other class. However, classes can implement more than one interface. So, for example, class car implements vehicle. How do we implement more than one interface? Well, turns out we can just put comma and then the other interface. So, for example, displayable. And of course, now I'm going to need the display method. So, public void display. And we have something like this. Now, the nice thing about this is we can have, for example, let's say we have a class rectangle, and we have something like length equals L, width equals W, and then public double area return length times width. And now we have rectangle implements displayable, and now we need a display method. So public void display print length by width. And now, for example, we can have, say, displayable. So we can have variables of type displayable. So displayable d1 equals new a7, displayable d2 equals new, say, car, and then red 160, displayable d3 equals new rectangle 57, and we can do something like d1.display, d2.display, and d3.display. We could also have arrays of type displayable. So for example, D1, D2, and D3 in here. And now one application is public static void display all with the displayable array. Assume that none of them are null again. Then just for displayable D in, for every displayable or element in the array, I just do d.display. So if I do, so currently this thing works. If I do display all DARR, it works again, and everything's going to be displayed twice. Once with the d1.display, d2.display, and d3.display, the other time with the display all method. And of course, we could have other things like class truck extends, implements vehicle and displayable, and so on. And that we would be able to create, like, for example, arrays of type vehicle that contain both cars and trucks. We would also be able to create like methods that accept as a parameter a vehicle or a displayable and do stuff like that. Now, here's another question. Can a class both extend another class and implement an interface? Well, it turns out yes. In fact, actually, for example, right here, A extends object and implements displayable. But in general, if we were to have to do this, so class B, let's just say that, class C extends B, implements displayable. That would be how we would do this. Basically, the class and class name extends, and then the class name we want to extend, and then implements, and then the interface, like that. And it turns out if we have like another thing, class D extends C, then for example, over here we have new B instance of B is true, new B instance of C is false, new B instance of displayable is false, as shown below. And then new C instance of B is true, new C instance of displayable is true, because, well, C implements displayable. And it turns out actually new D instance of displayable is also true. And that's because, well, C has the properties of displayable and D has the properties of C, because a D is a C. So basically D has the properties of displayable as well. Finally, say we have an interface E. If we have an interface F that extends E, then have another, say, useless method like that, then now all of a sudden, if we have a class, say G, that implements F, then we would need, if we just have useless 2, that wouldn't work. We would need both useless 1 and useless 2. So if we have both, if we implement both useless 1 and useless 2, it works. However, if we only have useless 2, it doesn't work. Similarly, if we only have useless 1, it doesn't work. So basically the way interface inheritance works is basically if interface extends another interface, it just inherits all the methods from there. One final thing to note is that interfaces don't extend classes. In particular, interfaces do not even extend object. Interfaces are interfaces, basically. Now, let's go back to looking at our definition of interface. It can contain abstract methods that are public, and it can also contain constants. So, first of all, in order to see that, we must first know what a constant is. So basically a constant is something that when I define it, it's a variable that when I define it and initialize it, I cannot change it. So u equals 9 would not be allowed. However, if I define it and don't initialize it, then I can initialize it. Now, be careful about that. In particular, if we have, say, final int w, we don't initialize it, then inside of this for loop that executes only one iteration, I do something like w equals 4. Is that allowed? No, because w is assigned in a loop. What if I do an if statement? Is that allowed? Yeah. However, what about w equals 5 now? No, w might have been assigned. What about printing w? Let's say we have Boolean right here, and we put it like that. Are we allowed to print w now? No, it turns out w might not have been initialized. Are we allowed to initialize w then? Well, turns out no, W might have been assigned. So my point is basically constants should usually be initialized or assigned when declared. And basically, that's what a constant is, something that cannot be changed. Constants can also be like static variables or instance variables. So for example, that is allowed and that is allowed. Notice that constants should usually be public, since you cannot modify them outside the class or inside the class anyway. The only reason we have private is because we don't want client programs to modify things, but these are constants, so they can't be modified. So they should be public. Other examples of constants are, for example, math.pi, which holds the value of pi. Basically, math is a class and pi is a static constant. So our interfaces can hold useless constants like that. And now constants in interfaces are always static, so printing f.x would be 789. Now, the final keyword right here can be used for constants. It can also be used for methods. So if we have a final method, that just means, so for example, class H public final void U. Then if we have class I extends H, all this means is that I cannot override U. So public void U is not allowed because that's overriding it. Even if I keep it final, that's not allowed. I cannot override final methods. That's what final methods are. And final can also be used in classes. So class J, let's just say I make it final. And basically final classes cannot be extended. So for example, class K extends J. That is not allowed. Now this raises an interesting question. Are we allowed to do final abstract class? Well, it turns out no, because it doesn't make sense. Abstract classes are meant to be extended, so we can't have final there. That's not allowed. Final interface, again, what is the purpose of that? That's not allowed. Finally, if we have an abstract class, let's just say N, are we allowed to have a final abstract method? Well, it turns out no, because again, abstract methods have to be overridden in subclasses. However, if we have it final, it cannot be overridden. That's a contradiction. So therefore, abstract methods cannot be final.